Correlation test. Hi all. Now in this video we'll be talking about correlation. Correlation is a test that we perform when our y and x both are continuous, right? There can be many examples. Maybe that your y is average call handling time, AST, and your x is a log in r, or say your y can be weight and your x can be height. Any two continuous data, whenever your y is continuous and x is continuous, you can do correlation. Okay, now when we talk about correlation, right? So it's good if we should also talk about correlation coefficient, right? Now what is correlation coefficient? The value of correlation coefficient will lie always between -1 to +1. That gives us idea whether any relationship exists or not, and if a relationship exists, then what is the nature of that relationship. Okay, so if correlation coefficient is 0, let's say I want to check whether there is any correlation between age and weight or not, right? So if I see that correlation coefficient is 0, that means there is no correlation between age and weight. That means there is no association between these two variables. But if my correlation coefficient is not 0, that means even if it's between 0 to 1, or it's between 0 to -1, that means there is some level of correlation. Okay, now if value of your correlation coefficient lies between 0 to +1, that means positive correlation exists. If value of your correlation coefficient lies between 0 to -1, that means negative correlation exists. Now positive correlation means if we increase value of one variable, value of another variable will also increase. Let me explain you what I mean when I say that. If, let's say for example, if I see that there is positive correlation between age and weight, that means as age of people increases, right, weight of people will increase. That means there is positive correlation. If one will increase, other will increase. Similarly, if your correlation coefficient is between 0 to -1, that means there is negative correlation. So negative correlation means when we increase one variable, when we increase value of one variable, another value of another variable will decrease. For example, say if I increase age, weight will decrease, though it sounds unrealistic, but I'm just telling you what negative correlation means. Okay, so this is how correlation coefficient tells us. So we use correlation test because correlation test first will give you idea whether any relationship exists between two continuous data or not. Second, this will give you idea if relationship exists, then what is the nature of relationship, whether positive correlation exists or negative correlation exists. All right, now again, because we are doing a hypothesis test, so p-value will be our decision making criteria. So if your p-value is, say, if your p-value is less than 0.05, then you would go with alternate hypothesis, and alternate hypothesis will say that there is significant correlation between both the variables. Okay, and null will say that there is no significant relationship between these two variables. Okay, now the very first thing you will do in any correlation test is, first of all you will check first of all you will conduct this test and you will check for p-value. If p-value is smaller than 0.05, then only you look at the value of correlation coefficient, because if your p-value is smaller than 0.05, that means significant relation exists. Okay, if your p-value is greater than 0.05, that means significant correlation does not exist. So in that case you should not look at correlation coefficient, because you know that significant correlation does not exist. Now let's see how do we conduct this test. So for correlation, you will have to go to basic stat, and in basic stat you will see correlation. Okay, now select two continuous data of your choice. Of your choice means of your interest. So my y is sales and my x is login r. dot is log NR. Okay, I'll do okay, and see here my p-value is greater than 0.05. So I would say that it's just greater than 0.05. Yeah, so I would say that no significant correlation exists. Okay, because no significant correlation exists, I will not see this value. This value is correlation coefficient, so I will not look that value. Okay, now generally if your p-value is smaller than 0.05, then only you look at correlation coefficient, and that will give you idea of the strength of relationship. For example, if your correlation coefficient is between 0 to 0.25, that means poor correlation exists. Okay, if that is between 0 to minus 0.25, that means negative poor correlation exists. If your correlation coefficient is say between plus 0.25 to plus 0.5, that means moderate relation, moderate positive correlation exists. If that is between minus 0.25 to minus 0.5, that means moderate negative correlation exists. Similarly, if your correlation coefficient value is say, if that lies between plus 0.5 to plus 0.75, that means a strong positive correlation exists. Similarly, if that lies between minus 0.5 to minus 0.75, that means strong negative correlation exists. Similarly, if your correlation coefficient value lies above 0.75, you say very strong positive correlation exists, and similarly in case of negative sign you will say very strong negative correlation exists. Correlation coefficient being 1 means perfect correlation, and then that's ideal situation. In real life you'll rarely see such situations. Okay, so this is how we do correlation, and I'm hopeful that now you understood what is the usage of correlation and why do we do correlation. Thank you.